Good morning, children. Today we are going to see the new chapter in physics, this motion. So first we can see uh, what is meant by motion. The term motion is defined as movement of any object from one position to another position with respect to the fixed frame. It means the movement of any object from one place to another. The movement is called as motion. Okay, so motion means movement of any object from one position to another position with respect to the fixed frame. So for example, if you want to go from school to one particular place, means you will be fixed in your mind that you have to go to your from school to your home. Yes, so that is the fixed frame. So we are moving from school to home or home to school is an example for motion. Okay, so movement of any object from one position to another position with respect to the fixed frame. So it is also said to be a change in position with time. Okay, so changing the position of an object with time is called as motion. Okay, so in our everyday life we can see some object at rest, others in motion. Yes, so birds they will fly, fish swim, blood flows through veins and arteries in our body, then car moves, then atom, molecules, planets, stars and galaxies are all in motion. Okay, so they are moving from one position to another position with respect to the fixed frame. Okay, so object will change its position when it is moving from one place to another with respect to the time. It is called as what? Motion. Now, so before going to the topic, we can learn about two physical quantities. They are vector quantity and scalar quantity. So what is meant by vector quantity? Vector is a physical quantity which has both magnitude and direction. Okay, so vector is a physical quantity which has both magnitude and direction. So what is meant by magnitude? It will describe the size of the object. Okay, so example is force, position, etc. Okay, so what is meant by force? Force, you know, no, force it has both magnitude and direction. Magnitude means we will say strong force, less force is applied. So that is the size of the force, and it has a particular direction. We will apply a force with a one fixed direction, with a particular direction. Yes, so force is a vector quantity, is an example for the vector quantity, and not only that, position also an example for the vector quantity. So we will move from one place to another with a fixed direction. No, we should go from one place to another, means we will fix in our mind that we should move from one place to another. We are changing our position from one place to another. So vector is a quantity which has both magnitude and direction. Now, scalar quantity. So scalar is a quantity which direction is not associated. Okay, it will describe only magnitude, which has only magnitude. It doesn't have what? Direction. Okay, for example, mass. So mass of the object, mass means, you know, weight. As so weight of the object, there we will consider only the size, we won't consider the direction. Yes, and temperature, temperature also we will consider the degree as hotness or coldness. We will not consider the direction of the particular object. Yes, so mass, temperature, time is an example for the scalar quantity. Understood, children? So vector quantity is a physical quantity which has both magnitude and direction. Example is force, position. Scalar is a quantity which direction is not associated. Example, mass, temperature, time. Now we will go to see about the motion along a straight line. Okay, now we are going to see about motion along a straight line. So when an object moves along a straight line, the motion of the particular object is called rectilinear motion. Linear means what? Straight. Okay, so when an object moves along a straight line, the motion of the object is called rectilinear motion. For example, if a car moving on a highway, it will move in a straight path, no? So it is an example for rectilinear motion. Okay, in a highway we can go in very straight path. Yes, the straight road will be. So the car will move in a straight path. So that motion of a car is a rectilinear motion. So when an object moves along a straight line, the motion of the object is called what? Rectilinear motion. Now we are going to describe about motion. Okay, so while describing about motion, we have to understand about two terms. They are distance and displacement. So now let us see what is meant by distance. So distance is the actual length of the path traveled by a body. Okay, so it is the actual length of the path traveled by a body. You know what is meant by pathway? Yes, so how much distance, that means how much length of the way which is traveled by any object is called as distance. Okay, so it is the actual length of the path traveled by a body. Then what is meant by displacement? It is the length of the shortest path. Okay, so we are moving from one place to another, but the length of shortest path which is traveled by the body from its initial position. Initial means from its starting point. Okay, initial position means from its starting point to its final position. Okay, it is the length of the shortest path traveled by a body from its initial position to its final position. Understood? It is the very shortest line which is traveled from its initial position to final position. Okay, so distance means it is the full, that means total length of the path traveled by the body. But displacement means it is the length of the shortest path traveled by the body when it starts from its initial position to its final position. And displacement is a vector quantity. Okay, so we know vector quantity means it is the physical quantity which has both magnitude and direction. So displacement and distance both is a vector quantity. And the SI unit of distance travelled and displacement is same. The SI unit of distance and displacement is meter. Okay, so what is the SI unit of distance and displacement? Meter. Okay, don't forget. So what is the SI unit of distance and displacement? Meter. Now we can see example. If a body start moving in a straight line, so the body, consider a body starts moving in a straight line. Okay, so it is moving from the origin. Here you can see in the picture, the object is started to move in a straight line from the origin O. Okay, origin O, and it moves through C, then to B, and reaches its final position, that is A. Okay, then again from A it moves back to B and reaches C through B. Okay, so now what is the distance traveled? We know distance traveled means it is the length of the total length, yes, length of the object traveled. Yes, so here from where to it started? From origin O to first it reaches to A, no, that is 60 kilometer. Yes, then from A to again it started to move back to B, then from B to C. So you count here from 60 to 25, how many kilometers? 35 kilometers. Okay, so the distance is the total distance traveled. So total distance traveled is equal to 60 plus 35. So the distance traveled by the body is equal to 95 kilometer. Understood, children? Now, what is meant by displacement? We studied that it is the shortest path. It is the very short path which is traveled by the body from its initial position. You have to note the point from its initial position to its final position. So from its initial position means from where it started. So from O to the short distance is O to C, no? So 25. Displacement is equal to 25 kilometer. Understood, children? So if a body start moves in a straight line from the origin O and moves through C, then to B, then it reaches to A, again comes back to the C through B. Distance traveled is equal to 95 kilometer and displacement is 25 kilometer. Understood, children? Now, types of motion. There are two types of motion. They are uniform motion and non-uniform motion. So first we can see what is meant by uniform motion. When an object covers equal distance in equal interval of time, it is said to be in uniform motion. Okay, so if the object covers equal distance in equal interval of time, then it is called uniform motion. What is meant by non-uniform motion? When an object covers unequal distance in equal intervals of time, it is said to be non-uniform motion. Okay, so uniform means that equal, as everyone will wear uniform in a same manner, as so when in the same equally we will wear, as so here also object if covers equal distance in equal intervals of time, it is said to be uniform motion. And non-uniform means if the object cover unequal distance in equal intervals of time, it is said to be non-uniform motion. Okay, so non-uniform motion we can say if a running race is there, one will cover the same distance in a one time, and another will cover the same distance in different times. So there is an unequal distance in equal intervals of time. It is said to be in non-uniform motion. Now speed. So speed is the distance travelled by an object in unit time. Okay, what is meant by speed? It is the distance travelled by an object in unit time. Unit time, particular time. Okay, so 20 seconds or 30 minutes or an hour. So distance travelled by an object in particular time is referred to as speed of the object. So it helps to measure the rate of motion of an object. Okay, it helps to measure how much the object is moved from one position to another. The rate. Okay, we can measure the rate of the movement of an object by the speed, with the help of speed. Okay, so what is meant by speed? It is the distance travelled by an object in particular time. Now, what is the formula for the speed? Speed is equal to total distance traveled by an object divided by time. If a body travels a distance, yes, now we are considering a body, it is traveling a distance, yes, okay, distance will be denoted by the letter yes. Yes, we have learned in 8th standard. Are you remembering? So, distance is denoted by the letter yes and time as t. Now, then its speed v is equal to distance by time, no? So, s by t. Speed has only magnitude, that's why it is a scalar quantity. Understood, children? Now, what is meant by average speed? How we can calculate average speed? Average speed of an object can be obtained by dividing the total distance covered divided by the total time taken. Okay, we have to divide the total distance traveled by an object by the total time taken. We can calculate the average speed of an object by dividing the total distance covered by the total time taken. Now, speed with direction. So, speed with direction is described as velocity. Okay. So, what is meant by velocity? Velocity is the speed of an object moving in a definite direction. Okay, moving in a particular direction. So, velocity is the speed of an object moving in a definite direction. Now, the velocity of an object can be uniform or variable. Okay, it can be uniform or it can be equal or it can be different. Okay, velocity of an object can be uniform or variable. It can be changed. How this uniform velocity can be changed? By changing the object speed, direction of motion, or both object speed and direction of motion. Understood? So, velocity means speed of an object moving in a definite direction. So, velocity can be changed by changing the object speed, direction of motion, or object speed and direction of motion. And speed and velocity have the same unit, that is meter per second. Okay, so what is the SI unit of speed and velocity? Meter per second. Understood, children? So what is the SI unit of speed and velocity? Meter per second. Okay, so we can also write it as ms minus 1 or meter per second also you can write. Okay, so velocity means it is the speed of an object moving in a definite direction. Now, when an object is moving in a straight line at a variable speed, at a different speed, okay, object is moving in a straight line but at different speed, then we can express the magnitude we can express the magnitude of its rate of motion in terms of average velocity. We can express the magnitude of the object or the magnitude of its rate of motion in terms of average velocity. Okay, now the velocity of an object will change when its position is changed. As when it changed, we have studied that when it's changed the speed or direction of motion. Yes, so when there is a change in the velocity at a uniform rate, the velocity of object is changing at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity. So, initial velocity means when it started, that speed, initial velocity. Final velocity means when it reaches from one place to another at a given period of time, that is final velocity. So average velocity is equal to initial velocity plus final velocity divided by 2. Okay, so initial velocity is denoted by the letter u. Okay, initial velocity is represented by the letter u, and final velocity is represented by the letter v. Okay, so average velocity is equal to u plus v by 2. Understood, children? So average velocity is how to calculate the average velocity of an object: initial velocity plus final velocity divided by 2, that is u plus v by 2. I hope that you all understand about distance, displacement, speed and velocity. So next class we can see about acceleration. So if you have any doubt, you can ask children. Thank you.